unless I see the original. So here's number 6. A random sample was selected from a population having a normal distribution. Calculate a 90% confidence interval estimate for mu for the situation parts A through D below. So in the first case, A, we have the sum of x is equal to 143. We have a sample size of n equals 10, and we have a sample standard deviation to be 3.1. So we're asked to calculate the 90% confidence interval. So let's do that. So we have the sum of x equals 143, we have n equals 10, and we have the standard deviation of the sample to be 3.1. So what I need to do is I need to formulate my interval. Mu will be equal to x bar plus or minus. We use the t-score since we're given the sample standard deviation and not the population, times s over root n, and that's the formula we use. X bar will be 143 divided by 10, which is 14.3. I need to find a confidence interval of 1 minus alpha to be 0.90, which means alpha is equal to 0.10. Alpha over 2 is 0.05 on either side. So the next thing we do is we go and see if it is in our table. If it is not in our t-table, then we have to use Excel to compute the proper t-score. So let's have a look at the t-table. So here's our t-table, appendix T and appendix F. We look up a two-tail confidence, right? We want a confidence level of 90%, which means one tail is 5%, the whole tail is 10%. So we look up 9 degrees of freedom because it's a sample size of 10. So since we're taking one sample, it's the degrees of freedom is 10 minus 1. So we look up 9 degrees of freedom, and we see that it is a score of 1.8331. Let's go back. So I know for this, my t-score will be 1.8331. So mu will be 14.3 plus or minus a t-score of 1.8331 times 3.1 over the square root of 10. This is 14.3 plus or minus, let's bring up our calculator, 1.8331 times 3.1 equals, divided by the square root of 10, equals, I got 1.79699, so I'm going to round that to 4 decimal places as indicated, so it's 1.7970. Sorry, let's type that again. 1.7970. I'm going to store that there. I know it's 14.3 for the mean, sample mean. So the sample mean minus the error is 12.503. And then it's plus the error, which is 16.097. So let's start with the first one, 12.503. So let's go back. So the 90% confidence interval is between 12.5030 and 16.097. Put a 0 4 decimal places, check my answer, and there you go. The next one, B, we have a sum of x to be 3648, a sample size of n equals 120, and a standard deviation of the sample to be 8.1 though. So 3648 is our x. Let's go back. The sum of x equals 3648. N equals 120 and s equals 8.1. So here I know that x bar must be 3648 divided by 120. So I'm going to compute that. That's 30.4. I know that I'm looking for a t-score. One second, please. It's a 90% confidence interval. So a 90% confidence interval means 1 minus alpha is 0.90, alpha is 0.10, alpha over 2 is 0.05. I'm going to look up my t-score. My t-score has to be, let's go back for a second. The t-score has to be n minus 1 degrees of freedom, right? So the degrees of freedom must be 120 minus 1, which is 119. So I bet it's not on my table, right? It goes to 90, 100. And you can use something close, but since it's the computer, it's going to ask you for a very precise answer. So I'm going to use Excel instead. So what we do is we say equals t, and we choose the inverse, t dot inverse. So the probability that we're looking for is 5% on the left tail and 5% on the right tail. 0.05 is the probability, and the degrees of the degrees of freedom will be 119 degrees of freedom. And I find that that is minus 1.6. I'm going to round that, right? 1.6578. 1.6578. So I know my t-score is 1.6578. Let's double check that. 6578. So I know that mu equals x bar plus or minus t times s over square root n, which means that this is equal to 30.4 plus or minus 1.6578 times 8.1 over the square root of 120. So that's 30.4 plus or minus, and I'm going to take my calculator. 8.1 times 1.6578 equals, divided by the square root of 120, and that's 1.2258, which means that we have to subtract 1.2258, and we have to add 1.2258 from 30.4. So let's go back. $30.4 minus 1.2258 is 29.1742, and 30.4 plus 1.2278 is 31.6258. And that's how you do that. Okay, and the rest will be the same, except in this case for C, we look up 8 degrees of freedom. Actually, let's just do it. Let's go back. If we look at C, we're given that the sum of x is 41.4. We have a sample size of 9. but we are given the population standard deviation sigma, not S. So we're given sigma to be 2.7. In this case, since we're given sigma is known, we should use the standardized normal table instead of the t-table. So we're given, again, sum of x is 41.4, n equals 9, sigma equals 2.7. So my confidence interval estimate for mu will be x bar plus or minus, and in this case, z, right, or z, times sigma divided by root n. We're using the standardized table since we know what sigma is. So, again, 1 minus alpha. Let's go back and see, make sure. We want a 90% confidence interval equals 0.90, alpha equals 0.10, alpha over 2 is 0.05%. So basically it's this on this diagram, right? 0.05 here, 0.05 here, and 1 minus alpha is 90% here. Okay, so x bar must be 41.4 divided by 9 is 4.6. I have to look up 5% on my standard normal table, right? So if I use the table, I look up 45%. If I use Excel, I don't look up that. I look up 95%. So look up table at 45%, right? Because the table only gives you from the mean upwards. So let's go to our Z table. Standardized normal table at 45%. Because remember, 45% gives you the shaded part, which means that you have 5% left over on the table. The closest I can come to 45% is between 0.4495, 0.4505. So since it's exactly between, I will take the average of 1.64 and 1.65. So the answer for that is, the Z score for that is 1.645. Okay, so let me redraw this for you to make it a little bit neater. Right, that's 5%, that's 45%, which is 0.45 by the way. So I know that this is 1.645 for z-score. So this way, I know that mu is equal to 4.6 plus or minus 1.645 times 2.7 divided by the square root of 9. So this is 4.6 plus or minus, I'm going to use my calculator, 1.645 times 2.7 divided by square root of 9, which is 3, and that's 1.4805. So my confidence interval estimate lies between 4.6 minus 1.4805 and 4.6 plus 1.4805. So let's go back. Enter it in here. 3.1195. And 6.0805. And there you go. And D, oh, before we do that, let's go and use Excel in case you want to know how to use Excel. So here's Excel. So what I'm going to do, erase that, is I'm going to start typing equals norm, and what I want is the inverse, the standardized inverse, so norm.s.inverse. Double click it. I'm looking for the probability, and in Excel, what happens is the answer that Excel gives is the area rolling in from the far left tail, rolling all the way to the right. So since I want 5% on the left tail, I put in 0.05, right? Close the bracket, and you see that it is minus 1.645. We round it to 4 decimal places, so 1.645. So I can also do it from the other table, equals norm dot s, right? Sorry, norm dot s dot inverse, and I will do 0.95, 95%, which is all the way to the right tail, except for the last 5%. Close that, and you see you get the positive z-score at 1.645 again. So that's the way you do it on Excel. The last question is very similar. You're given the sum of x to be 575.1, and you're given the sum of the squares to be 14901.89, and n equals 27. So in this case, x bar will be 575.1 divided by 27, which is the sample mean. And then you're given this data, which is the sum of x squared. So what they want you to do is they want you to compute the sample mean. So here's the formula for the sample mean again. So you know this is 14901 minus the sum of x is 575.1 squared divided by 27 divided by 26. Take the square root. That will give you s. Once you have s, you know this is a known quantity for the sample standard deviation. In this case, we do not use the standardized normal table. We use the mound-shaped table, which is the t-table. So we need to compute a t-score with degrees of freedom of n minus n equals 27 minus 1. So a degrees of freedom of 26. Again, I would use Excel to do this with a 90% confidence interval. So again, I would type equals norm dot s dot inverse. I want the probability to be, oops, sorry, not norm. I would type t dot inverse. The probability, right, is 0.05, and the degrees of freedom is 26, one less. Okay, and that is minus 1.7056 is the t-score that you would use for this problem. So I won't do that. I'll leave that for you.